Chapter 10, Problem 61. A long uniform rod of length L and mass m is pivoted around a horizontal, frictionless pin through one end. The rod is released from rest in a vertical position, as shown in Figure P10.61. At the instant the rod is horizontal, find A. its angular speed, B. the magnitude of its angular acceleration, C. the x and y components of the acceleration of its center of mass, and D. the components of the reaction force at the pivot. You are given length is equal to L and mass is equal to m. You are to find in Part A the angular speed, in Part B the angular acceleration, in Part C the x and y components of acceleration for center of mass, and Part D components of the reaction force at the pivot. For Part A, since only conservative forces act within the system of the Earth and the rod, the change in energy is equal to 0. So, using the kinematic equation for energy with kinetic energy and potential energy, Kf plus Uf is equal to Ki plus Ui. Uf is equal to 0 and Ki is equal to 0. And then subbing into the equation, the result is 1/2 I omega squared plus 0 is equal to 0 plus mg times L over 2, which is the height. In this problem, I is equal to 1/3 ml squared, and then substituting into the equation 1/3 ml squared for I and solving for omega, you will end up with omega is equal to the square root of 3g over L. For Part B, the summation of tau is equal to I alpha, so that in horizontal orientation, the potential energy initial Ui is equal to the summation of tau equal to I alpha. So mg times the height of L over 2 is equal to ml squared over 3 times alpha. And then solving for alpha, the result is 3g over 2L. For Part C, acceleration x is equal to acceleration r, which is equal to negative r omega squared, and that is equal to negative L over 2 times omega squared, because r is equal to the height, and that's equal to L over 2. And therefore, solving for ax is equal to negative 3g over 2. Acceleration y is equal to negative acceleration initial, and that is equal to negative ra equal to negative a times L over 2, and therefore solving for acceleration y, it is equal to negative 3g over 4. For Part D, we need to use Newton's second law. R sub x is equal to ma sub x is equal to negative 3 mg over 2. Then r sub y minus mg is equal to ma sub y equal to negative 3 mg over 4, using the equations you have learned from class. Therefore, solving for ry, it is equal to mg over 4.